Next up, we'll have a sort of tutorial type of session from Amin Hamidi Younessi, talking about IPv4 over IPv6 networks using RFC 8950. Take it away.
Hello, everybody. My name is Amin, and just a quick, overview about my background or something like that. I have been working around 13 years as an infrastructure network engineer in an ISP, and at the same time, from 2016, I started to traveling around the world on my holidays. Sometimes, in order to teach companies, ISPs, wireless ISPs, and privately some as a MikroTik certified trainer, and from 2017 to 2025 as a Ubiquiti certified trainer as well. And also, let's say in total, something around more than 7,000 hours I have been teaching technical courses like MikroTik, Cisco as a Cisco Academy trainer, and it will be continuing every day. So from these 2 past years, I instructing MikroTik courses within the European Union countries like Nordic countries and Baltic area as well. So with this topic, I want to talk about some challenges regarding IPv4 addressing. That's all we know. That one of the main problems of IPv4 addressing is it is exhausted from many years ago, and we have run out of these IPv4 addresses from many years ago. And as a customers who every day contact by the ISPs or service providers, they need to reserve a static public IP address or something like that. So in order to scale up their connectivity between branches, to connect multiple branches to each other, and the answer that every day they will receive from the ISPs, service providers, which will be, no, we don't have any extra IP addresses or any available IP addresses. And from the back in the days, from many years ago, I remember that when I took projects in different cities or countries, that I needed to connect factory, for example, or central office to their branch offices. Sometimes I needed to wait, for example, for 3 months or maybe more than that in order to find a free public IPv4 address or static IPv4 address, I mean, in order to make a tunnel or connection between them. So by less amount of IPv4 address these days, and the technologies like cloud computing and SDN technologies, all of these technologies, and IoT as well, there is no reason to continue with IPv4 only. Another problem is the transition needs to IPv4. It is essential. So if you want to, as a quick recap, to want to talk about what is the solution to continue with IPv4 addressing. So as you may know, from back in the days, many years ago, we find solutions. We had the solutions like a classless IPv4 addressing in order to make a few more room for IPv4 addressing to live, or maybe some other technologies like NAT or something like that in order to use IPv4 for a few years. But as you will see, most of the companies, service providers, and even the customers, they still need using IPv4 these days as well. So we are not fully IPv6 native, so we should run to the IPv6 faster in order to scale up our connections. So what were the old solutions for these problems? As we may know, dual stack is one of the technologies that we are using for many years. Means that for each and every links, we should have both IPv4 addressing or connection and IPv6 connection and addressing on each and every links. So the point is, the main point is, as layer 3 devices or routers or layer 3 switches, we have a complex management, double management, with much more overhead for our engineers. And also, every single layer 3 device is faced with a lack of performance or resources when they use a dual stack technologies. Another solution is about some kind of complex tunneling, and also NAT technology that you may know. For example, as a point of tunneling, maybe you prefer to use GREV6 or other layer 3 VPN technology or something like that, but the problem still exists, and our customers need to transfer or advertise their IPv4 addressing or routes. Another point is NAT, so network address translation, or NAT44, generated in order to make more room for IPv4 addressing for a few more years. Or another solution will be NAT 444, which is simply called double NAT, which is not efficient, as you may know as a network engineer in your production environment. When we make double NAT, well, it means that we increase the latency. Even with the simple NAT, we will increase the latency. And if you just imagine a large enterprise environments with thousands of users. For example, many years ago, I remember I was working for a company, for ISP, with something around 20,000 active internet users. Back in the days, on those days, I remember we had a 300 megabits per second, which is not a big deal these days, internet connection. And every day, our customers, our clients, suffering from the latency. Or just imagine that. Simply, they try to open a web browser, and they face with a delay, at least a few seconds each time, in order to see that web page. And we, as an infrastructure network engineer, we try to increase the bandwidth of an internet link, but the problem wasn't that. I'm like a speed of or bandwidth of a internet link. But what was the problem? Doing some NATs with IPv4 addressing, because back in the days we had only one IPv4 addressing, and behind each let's say IPv4 address, we can NAT or translate something around 65,355 devices. Now imagine that 20,000 active users, each of them try to make a different connection, use different application to the internet. And then how many ports? Imagine that within every single NAT devices like router, firewalls, we have something, we call it connection tracking table, which is the heart of every firewall and every NAT devices. Then you can monitor that how many ports will be generated in order to make these connections happen. So these are the problem. And also making it double NAT doesn't solve anything. So what is the modern solution? The modern solution, or as you will see, RFC 8950 introduced something new to us. And the idea is very simple. We still need to advertise IPv4 ranges, IPv4 routes, but instead of using IPv4 next hop, we can use it, we can encapsulate it in an IPv6 protocol. And how it will work, first of all, BGP is used, as I told you, as a point of view of ISPs or IXPs. BGP, or Border Gateway Protocol, try to advertise IPv4 routes with the immediate next hop of IPv4. But with the RFC 8950, it can happen by the next hop of IPv6 address. So it allows us to use high speed core network as a transitor or as a transmitter of a ISP's traffic, which they need, or customers, which they need to transfer their customers' IPv4 addresses. So what are the key benefits? The operational simplicity means that as a network engineer, we don't need to do any, more dual stack configuration or make a management double or something like that. And it will reduce the overhead, means less protocol management if you only use IPv6 networks. And obviously you have fewer configuration as well. So what about the scalability? As a scalability point of view, again, our customers, I'm talking about the enterprise level customers, just think about that a company with more than 100, for example, 1,400 branches which need to connect to each other by the technology. It is possible by the technology like SD-WAN or SDN or even clouds, or mixing the on-premise clouds with the public cloud as well. So by moving towards a pure IPv6 networks, we can scale up our network as well as advertising that IPv4 addressing scheme as well. And another important thing is RFC 8950 technically starts somewhere, if I remember correctly, around 2019 or earlier than that, from 2018 or something like that, but it introduced in 2020. Yeah. Yes, please.
So RFC 8950 is actually a redo of an older RFC called 5549, which is from 2009.
Exactly.
So it is like 16 years old.
Exactly. But RFC 8950, this RFC specifically, starts to solve this problem and introduced it in 2020, if I tell it correct. And RFC 8950 technically is not a new RFC. It is a something like a new benefit or new thing that's added to the famous multi-protocol BGP or MBGP. Because we all know that MBGP or multi-protocol BGP can carry some protocols like IPv4, IPv6, some VPN technologies like MPLS, VPLS, or something like that. So also MBGP allows BGP to carry routing information for these type of protocols that I mentioned. So RFC 8950 specifically define how to advertise IPv4 information or network layer information inside the IPv6. It's kind of encapsulation. I mean, that's when you want to route the packets, or advertise IPv4 traffic, you can route it to the immediate IPv6 as a next hop, instead of using dual stack technology or IPv4 next hop. So just as an example, when an IPv4 prefix like 10.0.0.0/24 needs to advertise to the BGP peer or BGP neighbor, let's say, it must be advertised as an IPv4, as I told you. But in this with this technology, we don't need it anymore. We can use the immediate next hop as a IPv6. So as you will see, the router advertises the same IP prefix, but the next hop is a global IPv6 address. And also we can use it in the intranet environment as well. Whatever we are talking about, we have the same thing on the WAN network as an example, like a internet connection, and also as the same thing as intranet as well for those large enterprise environments. And as you will see, it's a method like in encapsulating and transporting data, IPv4 data over IPv6 core only. And simply RFC 8950 names advertising IPv4 routes or networks, layer reachability information, or NLRI, but with the immediate next hop of IPv6. In this slide, as you will see, we have I use a simple picture that you may find in an internet as well. As you will see here at the bottom of the picture, we have an IXP fabric, or let's say network, IXP switch or switches maybe. And they benefited from, for example, a root server, which may be a Linux operating system benefited by BERT or I don't know, Go, BGP, which are familiar these days. And they're connected to the provider edge of each autonomous system, and each provider edge also connected to the core router and the ISPs in order to advertise the, for example, customers' IPv4 addresses. But the point is, from these peers can connect together just by using VLANing or different type of technology like VLANs and VXLANs or something like that on a large enterprise environment in order to make a BGP peer relationship together in order to pass the IPv4 traffic within the IPv6 next hop. So the interesting thing is when you're tracing the route of a IPv4 address, a specific IPv4 address, you will see the next hop or next hops by their IPv6 addresses instead of IPv4 addresses. And also you will see some transit routing between the maybe bridged router or BGP peer router as well. So in a for the practical demonstration, I mainly use EVNG as my emulator server or something like that, let's call. And I bring a few MikroTik router here within this area. And that Linux Mint operating systems just act as a customer in order to want to reach to other customers' IPv4 addresses. So these ISPs need to connect from the WAN side with each other as a BGP peer. But one thing that you may notice, I use the dual stack IP addressing. I use both IPv4 and IPv6 just as an example to show you how something simple can be more complex. But within the configuration, we just skip the IPv4 addressing. We just configure BGP by using RFC 8950. So, and also they connected to the IXP switch or IXP peer, and then they will transfer these IPv4 ranges within the immediate IPv6 next hop. So as you will see, I use MikroTik RootOS version 7.20 release candidate version 3, which launches a few months ago, and MikroTik interestingly support this RFC 8950 from a few months later. So but we may know that they release RootOS version 7.20.2, which is a stable version, which is more suitable for production environment. Otherwise, we should wait for the long-term release as well. But the point is, the simple export of a configuration is like that. So as at the first point, we should create an instance engine for BGP and then try to make a peer relationship between, for example, the ISP3 and other ISPs, as you will see within the picture. So one important thing is to verify the BGP peering session. From the routing BGP session within the MikroTik command line or configuration, you can see every peers with the E flag means the connection established. And another important thing is RFC 89 is talking about AFI and the possibility of using AFI and SAFI, which stands for Address Family Indicator or Identifier, and SAFI means Subsequent Address Family Identifier. So with the AFI configuration, we said that we want to use to pass traffics like IPv4 and IPv6 within this same, peer. And what is the difference between AFI and SFI? SAFI, simply AFI is suitable to transit. These are an extension for BGP, simply, let's say. And AFI is an extension to carry IPv4, IPv6, and L2TP VPN, just as an example. And SAFI is an extension to carry unicast traffic, multicast traffic, EVPN technology and traffic, maybe, and something like that. And from the next slide, you will see the next hop validation check by the route checking or showing the routing table of this MikroTik router OS, which shows us the network that we should advertise. We should reach them, but with the next hop of IPv6. So you will see the gateway or the next hop will be an IPv6 enabled only router. So it means that from the core, for the core network, core side of a network, we don't need to, for example, use dual stack technology or any other type of complicated VPN and tunneling solutions. One important thing is I forgot to put the template of my configuration within these slides, but another important thing is, as a result, in Linux 3 means customer behind the ISP3, which is need to connect to the Linux 1, which is behind the ISP1 in that previous picture. And again, you will see they both used, as a customer, they use their own IPv4 addresses. And by this, I can easily reach, and the connection is established from here directly to there. And the point is, it would be better if I remember to put another, a slide, just as I show you to remind. For example, when we're tracing the route, we will see every single next hop as an IPv6 with the IPv6 address. So by conclusion, this RFC try to level up our scalability for our networks, and the operation is more simple than before, like a dual stack, or compared to the VPNs and tunneling technology that's make our connections and configuration more, let's say, complex. And finally, future-proofing, it means that it's preferred networks to work as only pure IPv6 networks instead of using dual stack technologies. Thank you very much, and if there is any question, I will be happy to answer. Thank you very much.
Will you be staying for dinner and sauna?
Yes.
So
yes.
There will be plenty of time to ask questions.
Exactly.
So I've got a lightning talk coming up in half an hour or a little bit less, but one of the topics in my lightning talk is going to be upcoming nog.fi workshops, so those hands-on events, hackathons, and this is going to be one of the topics, so you can practice this in a lab environment, sort of, if you want, at that hackathon.
That's my pleasure.